Good morning. This is Rich Nass, Executive Vice President for Open Systems Media, and I'm here for this week's 5 Minutes With. This week, I'm speaking to Geoff Tate, who is the co-founder and CEO of Flex Logix. Good morning, Geoff.
Hey, good morning, Rich.
How are you doing today?
Oh, I'm doing great. It's a beautiful day out here.
Good. I'm glad to hear that. So you guys are into something that's referred to as an embedded FPGA. So before we get into why somebody should be interested in this or what it could do for them, what is it exactly? What is an embedded FPGA?
Well, like other IP before, SRAM or processors, an embedded FPGA is like an FPGA chip, except all of the outer ring of IOs is removed, and what's left is the core of the FPGA, the programmable logic fabric buried in a programmable interconnect, and now you can put it inside your chip.
When you say inside your chip, you're talking about a hard-coded SoC?
Correct. ASIC, microcontroller, there's a range of applications, but any kind of integrated circuit.
Okay, so why would I want to do this rather than a more traditional FPGA?
We're not replacing traditional FPGA. There's a big market for that. But there are things that you can do with an embedded FPGA that enables a chip architect to achieve things you can't do with an external FPGA. For example, internally, an embedded FPGA has hundreds or thousands of interconnects, all of which can run at hundreds of megahertz. So this gives you bandwidth into and out of the embedded FPGA that's impossible with an external FPGA. Applications like a programmable parser, for example, can have hundreds of pins coming in now with low latency and high bandwidth, and you couldn't do that with an external FPGA.
Okay, so I'm not sure if I understand the real benefit, because now you're back to the issue from a manufacturing perspective. Well, you sort of have to manufacture an ASIC anyway, so why not just use regular hard-coded logic?
That's just it. It's hard-coded, and the world keeps changing. So things like protocols in data centers, customers want them to be programmable now. When the data center guys are putting in chips, apparently what they're demanding is that the chips be programmable so they can keep up with changing protocols rather than do forklift upgrades every now and then.
Okay, that certainly sounds interesting. So is there a line like there is with a standard FPGA? If you want to produce more than X number of chips, it doesn't make sense, or if you want to produce less than X number of chips, it makes a lot more sense?
Well, standard FPGA is typically used for low volume production, and customers will switch to a hardwired ASIC as the volume grows. But the dynamics for embedded FPGA is different. Our customers are high-volume chip companies and will and are designing embedded FPGA into chips that are high volume.
Okay. And is there a manufacturing partner? I mean, is somebody locked into TSMC or something like that?
Everything that we've done so far has been for TSMC because they're the world's biggest foundry with a big margin and market share over anybody else. But our technology and embedded FPGA can be available on any CMOS process over time.
Okay. You mentioned data centers. What are the applications that really make the most sense for this technology?
There's a wide number, but where we're seeing the initial adoption is in networking and communications, in microcontrollers, and in aerospace/defense electronics.
And why is that? Why did you pick those?
Well, we didn't pick them. They picked us. We've been talking to a wide range of customers, and that's where we're finding the early adopters. If you'd like, I could go down each of the three.
If you can do it pretty quickly, because we're almost up against the time.
Data centers and networking need be able to adapt to changing protocols. Aerospace and defense already uses a lot of FPGA, but we can provide a rad-hard FPGA inside their chip. And microcontrollers in the past have had dozens of mask changes needed to support multiple types of communications protocols. We can give them one chip and save them $1 million per mask at 40 nanometers.
That sounds like a worthwhile endeavor for sure.
Yep.
Okay. And from the programming software side, does somebody need to learn your tools or using some sort of standard tool?
The customer programs with Verilog or VHDL. We work with Synopsys Simplify for the synthesis step, and then our tool does the back-end place and route. So it's easy to learn. We train people in half an hour at most.
Okay. And is this some technology that's unique to you guys, or are there others who offer something similar?
There are other people who are doing embedded FPGA, and there have been in the past, but the way that we do it has some unique aspects.
Such as?
A better interconnect that provides higher density, and a way to make the array size scalable. We can prove a couple blocks in silicon and then use those blocks to make larger arrays. That's something that other people can't do. Okay,
that sounds really interesting. Where would somebody get more information?
www.flex-logix with an X at the end of both words, .com.
Okay, that sounds great. Well, thank you very much, Geoff. I appreciate your time for taking the 5 minutes with me today.
Well, thank you, Rich.
That was Geoff Tate. He is the co-founder and the CEO of Flex Logix, and I'm Rich Nass with Open Systems Media. Have a great day.